Okay, hello everyone to our New Mexico Compost Coalition meeting for May, our Cinco de Mayo edition. I'm Navona Gallegos with the New Mexico Healthy Soil Working Group, and I'd like to just invite folks to do a round of intros. I will call on people, and I think we'll finish with Steve. And Steve, I can give a little bit of an intro as well.
Okay.
Before you launch into your presentation. So why don't we start with Rebecca?
Hi, everyone. I'm Rebecca Walden-Portick. I work at Compost Coalition, so we do a lot of compost work too. So interested to see this biosolids side of compost creation. It's something I'm curious about, interested in, worked with it a little bit, but wanting to know more. What else? I'm based in Denver, Colorado, and yeah, my background is in soil health, though.
Awesome, thank you. Noelle? Noelle, would you like to introduce yourself?
Oh, I'm sorry. Do you mean me? Sorry. Noel Lyons here with McGill Environmental Systems.
Ah.
Yeah, composting is my thing. Yeah.
Great.
Thanks.
And Christy.
Yeah, I'm a rancher here near Corona. We're getting a wind farm installed, and I'm looking for ways to help the rehabilitation once the construction is done.
Cool. How about John?
Hi, everybody. John Zarola, Bernalillo County Extension Master Composter. Good to see you all.
Good to see you. Thanks. How about Christina?
Hi, I'm Christina Salvador. I'm at the Santa Fe Botanical Garden. I'm director of their Science and Conservation Program, and I work closely with Linda Churchill, Director of Horticulture. So yeah, that's just your local garden, and we do have a composting operation now.
Awesome. Isabel, you're next on my screen.
Okay. Isabel Jeniches, also with the New Mexico Healthy Soil Working Group. Yeah, I'm really curious about what we get to learn today from Steve about the biosolids on rangeland, and oldie but goodie, right? So nice to see everybody.
Cool. Josh.
Hello, I'm Josh Waybright. I'm a soil food web type person, interested in all things soil microbes and food webs and compost and all that related stuff.
It's a webinar on composting in rangelands.
And then how about Jeremy?
Jeremy hired an AI to.
Hello, are you with us, Jeremy? Would you like to introduce yourself?
Hi, I'm sorry. My name is Jeremy. I live in Socorro. I am just interested in living soil, composting, regenerative soil.
Awesome. Sandra.
Hello, everyone. Sandra West, Sustainable Waste Specialist in the City of Albuquerque Sustainability Office. And also, this is a really exciting year for regional planning that I and many others across the state have been helping with. So this is especially relevant for that planning effort. Glad to be here. Thank you so much.
Awesome. So I think that is everybody who's in the room with us. Thanks for introducing yourselves. And sounds like a cool group of folks from around the state. And I'm excited to turn it over to Steve Glass, who is here with us from Ciudad Soil and Water Conservation District, and has been working on this project regarding biosolids on rangeland, and I am personally really excited to hear about it. I usually, when I'm driving through rangeland and arid lands, I actively wonder about how biosolids could be used. This is something I've wondered about for years, so I'm really excited to hear about the results from the research that you're going to tell us about. So I will hand it over to you, Steve. Thank you so much.
Thank you very much, Navona. I'll go ahead. Oh, a little, I guess, by way of introduction. So yeah, I've been on the board of Ciudad Soil and Water Conservation District for 21 years now, dating back, I guess. Well, actually, the research I'm going to be describing today started probably 20 years before I joined Ciudad Soil and Water. So this goes way, way back. I still consider, of course, the results to be applicable, especially to those of us who are concerned with degrading rangeland in New Mexico and elsewhere across the Southwest. Rebecca, with apologies, we're not going to talk a whole lot about biosolids composting itself, but I am happy to visit with you offline regarding that particular topic. What I'm going to be talking about is actually the application of uncomposted municipal biosolids to rangeland. So many of the conclusions that were reached with these studies will still hold true for biosolids that have been composted, but these studies were done with just dewatered biosolids from the Southside Water Reclamation Plant in Albuquerque. So we do have one person that joined us from on the phone. Do you want to get an ID on that person, Navona? 312-2690, or do we just
Sure.
jump?
Yeah, sure. Whoever just called in and is your alias is a phone number. If you'd like to introduce yourself, now's your time.
Or is someone who's, I don't know, you on the phone, 505-312-2690. Do you want to introduce yourself?
Can you guys hear me?
Yes.
Oh, okay. Sorry. I know that Zoom does like this, do a code to unmute. This is Sky. Hi. I haven't been to this meeting in so long. I work with the International District Healthy Community Coalition, and we do a lot of urban growing and whatnot. And I saw the topic, and this is actually somewhat related to my thesis. So I thought I would pop in and see what the good research is about. Thank you.
Great, welcome. All right, with that, I will go ahead and, oh, I didn't finish mine. So I graduated from New Mexico State University back in 1976 and had about a 45-year career in environmental science, both in research and local government. And somewhere along the line there, I joined the Soil and Water Conservation District, and I can say that it's been one of the most rewarding experiences of my life, professionally anyway. And I'm happy to say that we continue to pursue excellent projects like the ones I'm going to describe, although the Conservation District really wasn't involved in any of these studies. So with that, here we go. I'm going to share my screen. There we go. That, all right, you should be able to see that my my presentation.
Yep, we see it.
Pretty good. Okay, here we go. All right, so I'm really going to be talking about research that was done. You can see that over 20 years between 1981 and 2001 in using biosolids from the Southside Water Reclamation Plant for rangeland restoration. So here's kind of a photo of the kind of rangeland we need to restore in New Mexico and all across the West. This is my like section divider slide, so you'll see this a number of times. So let's just do some background. The federal government, Forest Service and BLM manage a bunch of land in New Mexico. In fact, I think New Mexico has one of the highest percentages of federally owned land in the nation, and we have a long history of overgrazing, with the result that the Rio Puerco watershed is characterized as the most erodible watershed in the nation. And you can see these numbers, very little flow, but a huge amount of sediment load into Elephant Butte from the Rio Puerco watershed, just west of Albuquerque, and 2,000 miles in New Mexico, streams impacted by sediment runoff. Paired with that, we've got the City of Albuquerque, or now the Albuquerque Bernalillo County Water Utility Authority, has a need to manage biosolids, what we used to call sewage sludge, which are produced during the wastewater treatment process that I will describe just briefly in a moment. And historically, what the city did was a surface supply, and until the biosolids right into the soil at a one section, a 640 acre plot out on the West Mesa. And over the years, that plot, which is still in use, to be honest, has become so loaded with biosolids that really nothing, not even tumbleweed, will grow there anymore, because the soil is so salty. And so that's becoming a liability, right? Because eventually that may be characterized as some kind of hazardous material site. So along with that, EPA, used to anyway, when EPA actually had some cred and weren't about to be eliminated from the federal government, they encouraged the beneficial reuse of biosolids through agronomic rate land application or composting. So obviously the Water Utility Authority way back when, and in the early 80s, started looking at those two opportunities, or two different ways to use it. So what are these biosolids? They're characterized as Class B under the Federal Biosolids Management Regulations, which is this 40 CFR Part 503 rule. What happens at the water treatment plant is that initially, what happens at a treatment plant is there's a sedimentation step, there's a biological decomposition step, and then there's a second sedimentation step to remove materials from the water column so that the water can be disinfected and released back to the Rio Grande. And so we have those primary and secondary residuals before and after the biological treatment that are captured and put into what's called a mesophilic anaerobic digester at the treatment plant, which is essentially, you could think of it as a steel cow stomach. It's anaerobic, it has multiple stages, and what happens there is that further biological decomposition occurs, so that some of the organic matter, in this case about 40%, 38% of the organic matter measured as total volatile solids, gets reduced. Right, by reduced, what I mean is that the organic matter is converted into methane, and actually the methane is captured and used to produce electricity for the plant, which is pretty exciting, but outside the realm of this talk. Anyway, at least 38% reduction in organic matter is required under the federal regs to make this material eligible for land application. So following that process, then there's a dewatering to remove, the stuff comes out of the digester at about 2.5% solids. And so there's a centrifugal dewatering step with some coagulant. It's it's a bulking agent, if you will, or a glue almost, that helps it reach 18 to 20% solids. It looks like a gigantic cow pie coming out of the centrifuges with very high nitrogen, 5%, and very low trace metals. There's a particular level for 10 trace metals in those federal regs, and the compost, or the biosolids that comes out of the treatment plant in the South Valley complies with the most stringent trace metals limits. So it's called exceptional quality. So what Albuquerque produces at the back end of those centrifuges is exceptional quality Class B biosolids that can be used with certain restrictions for agronomic application to rangeland or agricultural land, etc. All right, so moving on to some early research by the U.S. Forest Service Rocky Mountain Forest and Range Experiment Station. So in the early 80s, they were looking at all of this degraded rangeland over which they had responsibility, and had a hypothesis that organic, obviously you can use inorganic nutrients to try to reclaim rangeland, but their hypothesis was that organic nutrients would be superior, and they did a sort of a very small trial using these four organic sources to look at the effect on soil microbes, soil microbiology. They were looking specifically they looked at aerobic, it's hard to read a little bit, but they looked at aerobic microbes, they looked at streptomyces specifically, and then they looked at fungi in general. After application of these four types of organic surface treatments to degraded rangeland, and you can see here from the results is that overall municipal biosolids had the most significant overall effect on improved numbers of each of those three criteria in a rangeland soil after surface application. Manure, which actually this talk is a result of a U.S. I forgot her name, but she was here talking about manure sheds across the state, and their interest is to collect dairy manure and try to use it in a similar fashion. So it looks like dairy manure really encourages the growth of fungi, but not the aerobic and aerobic bacterial species in streptomyces so much, at least in that study. So that was the initial salvo, so to speak. Following that, 4 years later, the Rocky Mountain Forest and Range Experiment Station, BLM, and the City of Albuquerque collaborated on some watershed plot studies in the upper Rio Puerco watershed. Again, the Rio Puerco being the most erosive watershed in the nation. And so their objective was to look at soil chemistry this time, as well as vegetative response. So as you can see, here's the study layout, 16 plots that are 10 by 60 feet, surface application rates for biosolids at a control, no biosolids in these three application rates. And then they did no tilling and no grazing at all. And over several years, they monitored the impact of those applications. And so you can see the first year there was, in terms of soil nitrate, that soil chemistry was measured by soil nitrate. And in basically parts per million, milligrams per kilogram. And you can see there was an immediate effect, obviously, right after application, but that effect really endured over at least 4 and even was discernible after 8 years, which established that there is a long-term, very long-term benefit to soil nutrient availability by adding biosolids. And, you know, pretty much it looks like the more you add, the better the effect. They stopped at 40 for whatever reason, thinking that would be the high end and maybe it would become, they'd see some toxicity after that, but there was none observed. As we can see here, is that this is the foliar cover, just general foliar cover without any specificity. Again, and we can see that it took a year for the foliar cover, that is the number of plants per acre or plants per square yard, or plants per, I guess this is scientific, so plants per hectare, increased notably after 1 year, and that benefit actually endured for 8 years over the duration of the monitoring period there. So that was very encouraging that, you know, 40 dry tons per acre or lower actually have a beneficial effect both on soil nitrate and the foliar cover associated. So that one was actually published, that study, in the Journal of Environmental Quality in 1997. One major conclusion, this is the whole abstract, I won't dare read that, but the major conclusion here is that nitrogen mineralization potentials were much more, which were significantly higher after 9 years, indicating that site fertility remained higher, even though other soil chemical properties were returning to untreated levels. So that was really encouraging to see that the effect lasted so long, almost a decade, that they still had higher nitrogen mineralization potentials, that is availability of plant compatible nitrogen after almost a decade. Okay, next in 1990, we went out to the Ciudad long-term ecological research facility and did some plot studies on slopes. Okay, with, again, it was Forest Service, RMFRES, Fish and Wildlife in this case, because they run Ciudad, and the City of Albuquerque, obviously, for providing the biosolids. This is the first year I went to work for the city. So this was my first, all those other studies happened before I even showed up on the scene. So this was the first large study that I was able to get involved with. And so again, the part of the emphasis here was to look at the impact of surface applied biosolids on erosion, on like the loss of sediment from these test plots. And again, of course, there was a 2 application rates based on the previous study, 0 and 20 dry tons per acre. There were 6 plots that were 10 feet wide and 30 feet long, and 3 of them were at 6% grade, and 3 of them were at 11% grade, or I should say 6 at each grade. Okay, so a slight slope and a pretty steep slope, and they had these amazing runoff collection basins at the bottom with veins and redirects that would capture anything that ran off. Okay, so we also did, of course, vegetation monitoring. So what were the results of this guy? And primarily you can see that the application of 20 dry tons of biosolids, that is dewatered biosolids, directly onto the rangeland surface reduced runoff almost entirely, reduce, I shouldn't say runoff, but primarily what we're looking at is the sediment. And of course, if you're reducing the actual collection of rainwater from these plots, you know that there's no sediment being transported either. So this was a highly encouraging observation here, that applying just 20 dry tons per acre caused a complete cessation, if you will, of runoff from precipitation events that occurred over the period of study. You can see actually that we had anywhere from 10% to a quarter of measured runoff come off of the untreated plots, and of course, lots and lots of loose sediment coming off with those runoff events. So what were the effects on soil nitrate? Those plots, those 30 by 30 plots were sampled, and over a period of, so pre-treatment, fall of 91, spring of 92, and fall of 92, at pretty much the surface, just below the surface, and then deeper into the soil column. And we have the blue is controlled, there's the controlled, and then we have the yellow is treated. And clearly you can see that the application of this 20 dry tons per acre of biosolids had an immediate and long-lasting effect at the surface. And then you can see that over time, we can actually see evidence of nitrate. That was the soil nutrient measure, of soil nitrate migrating through the soil column into the deeper root zones, where those very deep rangeland grasses can make use of it. So this, again, very encouraging results regarding soil nitrate. Then looking at foliar cover, again, pre-treatment, fall of 91, spring of 92, fall of 92. Foliar cover being a measure of, just the percentage of the property with plants on it, so there's vegetation on it. And you can see that there was the usual like 1 year delay. Of course, you have to go through a growing season to see that result. And then we saw a year later, after pre-treatment, we saw a significant, I shouldn't call it scientifically significant. We saw a noticeable increase, maybe 10 percentage points from pre-treatment to the spring of 92. Fall of 92, it looked, oh my goodness, something happened. Well, what happened was there was a very low precipitation year so the monsoons really didn't happen in 92. So actually we got some die off, and again, a little hard to say that there's any significant difference here. There was at least an observational reduction of plants more on the treated site than on the untreated site, which is a little maybe a little concerning, but it's as far as the study went. So who knows what might have happened in years after that. Still, this overall was an encouraging result of putting biosolids on rangeland. So we then took this out into the San Luis area, again in the Rio Perco watershed. And this was a really fun one to set up because the study site was right under the Cabezon. So every time we would go out and take data, we got to be out there, with Cabezon looming in the background. And that's such an impressive volcanic throat to be near. So we had a lot of organizations involved in this particular study. And again, we're going to try to confirm former studies and look at logistics for larger scale projects. And this one involved sloped watershed that was sort of shaped like maybe a I don't know, like a heart shape. It had they had a central drainage with two very similar sub watersheds on either side of the central drainage, like about 65 acres on one side and 65 acres on the other. We did another biosolids surface application at 20 dry tons per acre. So we had some considerably larger hurdles to get over. We had to do an environmental assessment under NEPA because it was a federally funded project on public land. We got NMED to waive the groundwater discharge permit that normally would have been required in the name of, so they were interested enough in the research that they got a waiver. We had to get BLM buy-in and their support to build a fence around the study site so we wouldn't get any grazing in there. And then unfortunately, 3 years after the installation of this project, the funding was withdrawn after RMFRES went through a reevaluation of their programmatic priorities. There were logistics too. It was 120 miles from the treatment plant to this study site. And then so I'm kind of amazed, but the city permitted me to spend $85,000 to haul biosolids from the treatment plant out to this study site, enough biosolids to cover that 65 acres at 20 dry tons per acre. We had a hauling contractor for a while who flaked out on us, so we had to actually recruit our own biosolids, our own sludge haulers that had to be diverted away from the land application site on the West Mesa. We had equipment failures, of course. We had freezing sludge, couldn't calibrate the spreader very well. We finally got 10 dry tons per acre applied. I think that was the actual final application rate, 10 dry tons per acre, because we couldn't quite get it to 20. So as we saw from that previous study, 10 and 20 in terms of foliar cover and foliar response is kind of not a huge difference. Anyway, what did we see? We looked at first, again, soil nitrate as a measure of improvements in soil nutrient availability. So we measured for a year after application. We actually started in 1995. I'm sorry, this was 2 years after the application. We had data collected. There may have been data before this, but it didn't get into this graph. We can see, however, though, 2 years after application, we're still seeing very significant increase in soil nitrate, both at the surface, 0 to 10, and at depth, 10 to 20. And here we are 3 years after application, still seeing significantly different soil nitrate levels, both at the surface and at depth. So again, very encouraging that soil nitrate was being mineralized. Soil, let's say organic nitrogen, continued to be mineralized into nitrate over the period of time of measurement. And we looked at classes of vegetation in this case. So pre-treatment, here's control versus treated for grasses, control versus treated for forbs, and control versus treated for shrubs. So grasses and forbs are things that are valuable to cattle grazing. Uh-oh, I went one too many. There we go. For cattle grazers, and these shrubs are not. Shrubs tend not to be of high value for cattle grazing. So anyway, we obviously saw the biosolids treatment increase grasses, noticeably increase, at least not have any, well, actually increase forbs over a long period of time, and actually showed a decrease in the shrubs. So that was kind of encouraging, looking at all those classes, because the shrubs, what we were looking at was broom snakeweed. So broom snakeweed is the bane of cattle ranchers, because broom snakeweed causes deleterious health effects for cattle who eat it. And so we were happy to see that our treatment with biosolids actually caused a decline in the percent foliar cover represented by snakeweed over the 3 years following application. So that was very encouraging in turn, and likely this is a result of the stronger growth of the grasses and forbs that were out competing this snakeweed. But the snakeweed is basically not an invasive, but a pioneer species that moves in when you have degraded rangeland. It's really requires some degraded rangeland conditions in order to thrive. So this was also promising information. Okay, that all led us to our first, and actually only so far, full-scale public-private partnership starting in 2001. And again, the wastewater division, the City of Albuquerque, the open space division of the City of Albuquerque, Black Cattle Ranch, which actually was a private firm, and NRCS, the Natural Resource Conservation Service, who helped us do a lot of objective plan reviews and sampling and follow-up. So that added credibility. And we wanted to, just demonstrate that this could happen, that biosolids mediated range restoration could happen on a full-scale site with a public-private partnership. And of course, we committed to monitoring soil, vegetation, animal effects of any application. So we had almost 4,000 acres of private land and 1,200 acres of public land, which turns out there's a grassland preserve, little known grassland preserve out on the West Mesa that's 1,200 acres in size. And the open space division of the City of Albuquerque is in charge of that, of managing that. So there were many presentations to the Open Space Advisory Board about, yes, we're not going to harm your property, and we need to cut a road next to it to get to the private land, et cetera, et cetera. So it was a kind of a big lift, but we designed an application rate of 10 dry tons per acre, and promised to do annual assessments of soil, vegetation, and the cattle health. Here's kind of a rough diagram of where we worked. This right here, this kind of strangely almost triangular site, is the land application site that the city was operating at the time, 20 miles west of the wastewater treatment plant. Within there, Rebecca, you'll be happy to know, is the biosolids composting facility that was built in about 1989. So it was up and running, and we were diverting somewhere in the range of 15% of the biosolids from the treatment plant into this composting facility for, reuse in uncontrolled applications around the watershed. We still had this giant, well, not that big, 650 acre heavy application disposal area going on. and a new jail, which is now the West Side Homeless Shelter, was built on about 6 acres right there. And then in here we had trust land, the open space trust land. And over here we had the $3,800 that was called Black Ranch. All right, so there's our setup. And then here's our kind of our application design, right? So here's how where we were hauling the biosolids or the sludge to begin with. And we designed these let's see, they were 100 acre, or I think they were 100 acre. No, they're a little bit more than that because this is 30. I don't remember the exact size, to be honest, but we just drew these things out there and numbered them. And here's our application, biosolids application design schemata, where we would just go back and forth with our sludge spreader that was used down here to just heavy duty apply sludge. And we just applied it at a much lower rate, what's called an agronomic rate, 10 dry tons per acre, and monitored and for responses. Okay, lots of planning went into this. So we had to have approval from the Open Space Advisory Board. We had to have a lease agreement and an MOA with the trust land and with the private landowner. We had to get the mayor's office, the Parks Department, the Public Works Department, all to sign off on it. We had to make sure that there was water for the cattle out there. We had to modify our biosolid spreader because it wouldn't do of 10 dry tons per acre without increasing the number of flails. And basically these spreaders are just huge, giant pickup trucks with these rotating like flails on the back side that just fling the biosolids out the back of the thing. And we needed to increase the flail density. And even so, we were only able to do 7 dry tons per acre, which meant we could do 1,150 acres per year. We had to cut a new access road. We had to provide a break area out at the operational site for our operators. And we had to provide for a 1-year public access control and a 30-day grazing delay schedule in accordance with those biosolids regulations from EPA. So finally, in 2001, in April of 2001, after a whole bunch of stuff, permit issuance, roads, buildings, we finally started applying biosolids in 2001. And here is some of our application rates. And you can see that we were able to apply through, only goes through February of 2002. This is the furthest data that I have. Honestly, I don't know why I don't have the data from this study. It's been 23 years, so I don't I don't remember why I don't have the actual data. What I have is the application rate and some anecdotal results from the rancher. Is that there was a significant drought again in 2002, and while his fellow ranchers were selling off their herds because they could not feed them on their allotments, he was able to maintain his entire herd throughout the drought, and he never saw any adverse health effects for his cattle. So I'm unable to share with you any actual data from that, but I'm hoping that the data from the previous studies is sufficient to convince you that the soil nutrient and foliar cover rates were also similarly beneficially affected. So looking forward to rangeland reclamation with biosolids. We have this new bugaboo out there, the PFAS. I'm sure many of you have heard of PFAS, per and polyfluoroalkylated substances, aka forever chemicals that have been around. Like PCBs, they've been around since the 1940s. They're highly carcinogenic. They cause immune effects, reproductive effects, fetal development effects, and the EPA has pretty much just recently started moving toward regulation. So they have a strategic roadmap that they issued 4 years ago, but have not yet established MCLs or maximum contaminant levels in any environmental medium, let alone biosolids. They're also notoriously difficult to measure in very, very organic matrices like biosolids. In fact, I just saw, here it is, 3 days ago, there was a great article in Bloomberg Law about entitled PFAS and Fertilizer from Sewage Sludge Spurs State Control Efforts. 20 bills in 12 states have imposed bans or testing requirements or disposal guide, all kinds of things for using biosolids on farms because of concerns over PFAS. And on the other flip side of that, wastewater utilities like the Water Utility Authority are saying, well, you know, using farms and ranches and large agricultural applications at agronomic rates is a very beneficial way to use biosolids. And without those alternatives, we will be very limited. In fact, what the City of Albuquerque did before moving out to the West Mesa to do land application, as I described at the beginning of this presentation, is that they would simply take the sewage sludge from the treatment plant, dig gigantic trenches right next to the landfill, pour that sewage sludge in there, and cover it up with dirt. So you can imagine the nutrient and microbial load on the groundwater underneath that landfill. So land application is really a pretty good alternative for biosolids disposal, and eliminating that opportunity or that alternative with any of these bills or these rules could really impede it could have significant environmental impacts. So I have heard recently, anecdotally, that the water utility has tested its biosolids compost and found PFAS in the compost, but according to them, they also looked at the feedstocks for their biosolids compost and said that they only found PFAS in chipped up shipping pallets. I'm sure that you will find PFAS in shipping pallets because that wood is treated to make it, durable. And you can imagine that PFAS is part of that chemical mix that is used to treat that wood. My suspicion is that the biosolids matrix is so complex organically that picking out something as unique as PFAS may be difficult. So saying they're not in biosolids is questionable to me. So looking to the future of erosion control, we really can't predict. Who knows what's going to happen? I would still say that using municipal biosolids, based on all the experience that we've had, especially with that large scale application, public-private application, that is still a good alternative. And we just need to confirm that whatever PFAS might be in biosolids are not going to have any health effects on cattle grazed on that kind of on that kind of treated rangeland. If you're not grazing cattle, obviously it's not an issue because, you know, the PFAS are just going to eventually, through ultraviolet radiation, one would hope, disappear. But it might take centuries. I don't know. Nonetheless, that's all I had today for that summary. I'm going to stop sharing my screen and come back to you all, and be more than happy to answer any questions or provide clarifications. Thank you for your attention today.
Thank you so much for that presentation, Steve. That's a really interesting history and a pretty long, compelling history for the use of biosolids on rangelands. Wow. I, for one, had no idea that there was such a, yeah, so many different research projects going on in the state over so many decades. Yeah, does anyone have any questions? There's a couple questions in the chat. Some are from me because I was trying to keep track, but I also just want to open it up for questions if anyone wants to ask one verbally.
If I may, Noel here. Thanks, Steve. That was excellent, by the way, absolutely excellent. I had some background noise at the very, very beginning or towards the beginning, and you were talking about extremely high salts. And I wasn't 100% sure, was that from extensive repeated biosolids, or was it from some other source?
No, that actually, I was referring to the heavy duty repeated application of biosolids on the disposal area out on the West Mesa, not the agronomic rate.
Okay, all right, excellent. Okay,
yeah.
But very informative. I learned. I've been composting biosolids for almost 30 years, and I learned quite a bit from your presentation, particularly on the nutrient mineralization after you said year 9, I think, going on that long. That was very interesting. Very interesting. Yeah. So thanks again for that.
Sure thing.
That was all. Yeah.
Yeah, I was curious as well about the application rates and if 40 tons per acre is starting to hit a rate that can create accumulation of salt, or if there's a reason that was the upper limit in that particular study.
You know, that's just, there was no scientific reason to stop there. It was just that's as high as they decided to go. That's all. Yeah. What is the let's see, we have other questions in the chat here. Do any of those steps of filtration remove pharmaceuticals? Oh, that's a great question, Jeremy. Typically, pharmaceuticals will associate with the solids, not always, but so we get a partition of the pharmaceuticals between the collected, when I talked about the collected sedimented organic matter that goes into the digester, but some of the pharmaceuticals actually make it to the river, of course, and we've all heard about that and how the boy fish becomes effeminate in discharges. And we've actually measured, someone did a study on pharmaceuticals years ago on pharmaceuticals in downstream of the Santa Fe and Albuquerque wastewater treatment plants, and found a lot of what is the word I'm thinking of? Antidepressants in Santa Fe, and a lot of stimulants in Albuquerque for some. So no, I guess in short answer to your question, Jeremy, no, these filtration steps are not designed to remove pharmaceuticals, but my thought, since pharmaceuticals tend to be organic chemicals, that the composting facility, or the composting process, I should say, the process at the compost facility, being high temperature and very, very high biological activity should be pretty effective at decomposing some pharmaceuticals. And there's very little work being done on pharmaceuticals in compost. I've found only one paper. So Navona, what is the coagulant? It's a nitrogen-based polymer that it's got a trade name, and it's essentially just it's got a charged end and a non-charged end, and the charged end attached to the particle, and then the non-charged ends clump together and pull all the particles together. If that makes sense.
Curious. Yeah, I mean, I can envision it. I am still curious how that might affect the actual material. You know, if it's nitrogen based, I wonder if that is contributing at all to the nitrate levels.
Oh yeah, it's definitely a part of it. Part of the 5% nitrogen that we measure in the dewatered biosolids, it comes from that polymer. But the polymer is added at like 1% volume to volume, so it's a tiny fraction. Most of the nitrogen comes from biological nitrogen, which is proteins and nucleic acids from the microbes themselves. Application, okay, Christy, application did not stop after 2002. It's just that 2002 is when I created the original study, or the original presentation that this presentation is based on. And so I never had an opportunity to update it. And then I moved on. And so the data is there, but I have no more access to it. So that's just, it went on for another, oh gosh, it went on for another 4 to 5 years at least. And I will say that the rancher then had sort of a falling out with the guy that ran the sludge program for the city. And it evaporated after that, but I'm not sure exactly what year. It did continue. And I imagine if we went out there today to that Black Ranch area, we could actually see some residual effects, but I don't know. Yeah. Any other question? Looks like we're kind of right on time.
Yeah.
Yeah, really quickly, maybe just like a follow-up on that. So right now, this is no longer being done. I mean, I'm
Right.
actually so impressed with the results, including, like on fungi, on soil health, on the snakeweed reduction. I'm like, wow, why are we not doing this, right?
Well, yeah. I agree, Isabel, for sure. But personalities get involved, and it was actually that rangeland reclamation is a bit more, well, significantly more expensive way to dispose of biosolids than that high rate land application on one spot. It may be comparable to composting, but it requires all of these agreements and interactions. And so it gets to be a little complicated, so obviously it hasn't been pursued, but it's still a great option as the data indicates. So
Interesting. Are the legal challenges mostly when it is a public-private interaction, or would it change a little bit if it was, say, going to BLM land?
Well, it could, but it might even be more complex with BLM, because BLM is a big federal agency, and to get clearance to use their property is like pulling teeth and all that. So it's just the partnerships, the agreements that have to happen between the biosolids producers and the biosolids recipients tend to complicate things, and that added on top of the you know, you got to haul it further. You have to burn more fuel to apply it at a lower rate, and you know, all that kind of stuff. So, I mean, I still think it's a great option, but obviously my career took me in other directions, and I didn't follow up on it, and nobody else did when I left. So, but here we have a whole new crew of all you great people, and let's see what we can make happen, right?
Awesome. Well, thank you so much, Steve. Are there any
You bet.
other questions or comments?
I'll share with you the slides if
Thank
you'd
you.
like to put them on the website. And I'll be open to any other questions if they pop up later.
Great. Well, thank you for catching us up on decades of research in 1 hour.
You betcha. It was fun to revisit all that stuff. Too bad I didn't have stuff after 2002, but that's life. Okay. Well, then I guess we'll see you all next time.
Thank you,
Yeah.
Steve. Thank you.
Okay. All right. Adios.
Thank you.